Okay, guys, today we are going to talk about the volume of a sphere. Now, this lesson is a little bit difficult to do on a smartboard, so hopefully this will come out okay. But we want to look, how did they come up with the formula for the volume of a sphere? And I know most of you already know that formula is 4/3 pi r cubed, but we're going to prove it today. Okay, so before we can do that, we have to understand something called Cavalieri's principle. Cavalieri was an Italian mathematician. He came up with the idea that if two three-dimensional figures have the same cross-sectional areas at every level, then the two figures have equal volumes. So what would that mean? That would mean something like this. If I had a cylinder, okay, and I had a prism, and I took a cross section at each level. So what I'm doing is I'm slicing this thing here, and I'm looking at that shape right there. And at the exact same height, I'm taking a cross section of this, and I'm looking at that. So I'm going to get a circle here and a rectangle here. If that area of that circle is equal to the area of that rectangle, anywhere at any level that I take this, then the volumes of those two shapes have to be the same. Okay, so how does that help me? Well, we have a surface area of a sphere is 4 pi r squared. We're just going to kind of get that out of the way right there. We'll talk about this a little bit in the next lesson, how they derive that. We're going to look at the volume of a sphere is V equals 4/3 pi r cubed. Okay, how in the world did they come up with that? This is what they did. I thought this was rather ingenious, okay? So they took a sphere with a radius of r, and then they took a cylinder that had a radius of r and a height of 2r, okay? So remember, the diameter of this is then going to be 2r. So this sphere and this cylinder are exactly the same height. They're exactly the same distance around. And then they cut out two cones out of the inside of this. They scooped out this cone, they scooped out this cone. So you got kind of this weird hollow shape that was solid in the middle, but as you get bigger and bigger, it has like a ring shape, and the hole in the middle of the ring gets bigger and bigger and bigger until you get to the very end of this, and then there's nothing left, okay? So these are the same height. Now, here's what they did, is they said, okay, if we take a slice at the very middle of this, the area of this circle is pi r squared, and the area of this circle is also pi r squared. So that's a good sign. The areas in the center, the middle of these two things, is the same, okay? Now what we need to do is we're going to take a cross section of the sphere. Now, as I go higher and higher up the sphere, the circle that I get as a cross section is going to get smaller and smaller. So the area is going to shrink, okay? Now here, what happens in the cylinder, the outer circle stays the same all the way up. But what's going to happen is, as I move up, I get a hole appearing in the center of the circle. And as I move up higher and higher, that hole gets bigger and bigger, okay? So the area is going to get smaller and smaller. What I want to do is I want to show that the area of this circle here is going to be this area of that ring over there. So here's what I'm going to do. I need to grab, to make this work really nicely, I'm going to grab a couple of things. Okay, so if we look at this, this right here is r, and this right here is r. Now, that tells me that that triangle is going to be an isosceles triangle, okay? An isosceles right triangle right here. That's going to be a 90-degree angle, okay? And what's going on here? But that's going to tell me that this is a 45-degree angle right here, which is going to be important, okay? So that's R and that's R. Okay, now let's grab this. We'll drag this up here. Okay, and we're gonna drag this up here. Okay, so what that's gonna do is, oops, let's see here. Yeah, this is really hard to do on the smartboard here. Okay, so what I've got here is I've come up a distance of h right here. Okay, and I've got another circle that I take a slice right here at that level, and I want to calculate the area of that circle. Okay, so in order to do that, I need to know what is the radius of that circle right there. What is x? Okay, so this is a 90-degree angle right here. So I'm going to use the Pythagorean theorem, and that's going to tell me that the leg squared plus the leg squared equals the hypotenuse squared. So h squared plus x squared equals r squared. That tells me that x squared equals r squared minus h squared when I subtracted the h from both sides. And that tells me that x is going to be the square root of r squared minus h squared. Okay, so now I can calculate the area of that green circle right there. So that area is going to be pi times its radius squared. But the radius is this, so it's going to be square root of r squared minus h squared squared. Well, all that squared is going to do is eliminate that square root right there. So this is going to become area equals pi times r squared minus h squared, which is just pi r squared minus pi h squared if I distribute it. So this is the area of that green circle. Okay, so we can put this right here. Area is pi r squared minus pi h squared. Okay, now what I'm going to do here is I'm going to come up that same height, h right there. Okay, so this distance right here is exactly the same as this distance right here. Okay, and I'm going to take another cross section. Now that's not going to give me a circle. Somewhere I had a ring and apparently I lost it. So here's what it's going to give me. It's going to give me a ring like this. Okay, so now I gotta find the area of that ring right there. Okay, so let's kind of just draw it down here. So basically I've got a circle with another circle in the middle. Okay, now see how this is a 45, 45, 90 right triangle right here. Okay, so that means if this is h going up here, this has to be h going right here. So the inner circle is going to have a radius of h. The outer circle is going to have the same radius as this. It's going to have a radius of r. So the area of the ring, which is this blue part right here, the area of that's going to be the area of the big circle, which is pi r squared, minus the area of the small circle, which is going to be pi h squared. And hey, that's exactly the same thing as that right there. And so it doesn't, since I used a variable, I came up a distance of h. It doesn't matter what that number is. I could go anywhere between here and here or down here. I come up the same height here. So that means that this circle is always going to have the same area as that ring right there. So this tells me that by Cavaliere's principle, these two things have to have the same volume, okay? So since this is a proof, we need to actually write this. So by Cavaliere's principle, since area of the circle is always equal to the area of the ring the two shapes must have the same volume. Okay, now what does that help me with? Am I done with my proof? No, I'm not done with my proof. But here's the thing. This is very hard to find the volume of if you don't know the formula already. This is very easy to find the volume of. So I can find the volume of this, and that's going to equal this one, okay? So how do I find the volume of that? Well, we know that that's going to be the volume of the cylinder minus the volume of the two cones. Okay, so volume of the cylinder. That is going to be the area of the base times the height. So it's going to be pi times the radius squared times the height of the cylinder. Okay, and then the cone has a height of r and a radius of r. So it's going to be minus. Now there's two cones, so I'm going to double. The volume of a cone is 1/3 pi radius squared times the height, but the height is just, we'll do this here. We'll go a little h for the height of the cone. We'll go a capital H for the height of the cylinder. Okay, now, here's what we know. The height of the cylinder is 2r. Okay, so if we go back here and we look, this is r and this is r, so that's 2r. Okay, minus 2 times 1/3 is 2/3 pi r squared times r. That's the height of one of the cones, because the height of the cone is going to go from here to here. Okay, so now it's very simple. I just finished this up. The volume is going to be 2 pi r cubed, if I multiply this together, minus 2/3 pi, this multiplied together is r cubed. So if I have 2, remember that 6/3 is 2, minus 2/3, that's going to be 4/3 pi r cubed. And that, my friends, is how they came up with that formula. Okay? So, that's a pretty tough little proof, but I think you could, hopefully you got it. Okay, now we're going to go ahead and using the formula is actually much easier to do than proving it. Okay, so find the volume of the sphere. Okay, well, volume is 4/3 pi r cubed. Remember, we always write down our formula, and the radius is 9 in this case. So let's see, 9 cubed, that's 729, I believe. Let's just, yeah, 729. Okay, so then I'm going to go 729 times 4 divided by 3. That's 972 pi. So times 3.14, that's approximately 3,052.08 cubic centimeters. Okay, so there is my formula, or my volume. Okay, so exact answer, approximate answer. Now we're going to find the surface area. So surface area, we said, was 4 pi r squared. Okay, so since r is 9, we get 4 pi times 81. So 4 times 81, that's 324 pi, so times 3.14, that comes out to approximately 1017.36, and that's going to be square centimeters this time. Okay, there you go. So pretty easy to do once you know the formulas. All right, now we've got this formula right here. Now, this is like a capsule, okay? So basically what we're going to do is we're going to find the volume by finding the volume of the cylinder and adding it to the volume of a cone, because I've got, or a sphere. I've got half a sphere up here and another hemisphere down here. Okay, so the volume of this shape is going to be pi times the radius squared times the height plus 4/3 pi r cubed. That's a terrible cube, isn't it? Okay, so very simple to do. The radius is 8, so pi times 8 squared times 10 gives me the volume of the cylinder, and then 4/3 pi times 8 cubed gives me the volume of the sphere. Okay, so let's see, this is 64 times 10, this is easy to do, 640 pi plus 8 cubed, 512 times 4 divided by 3, that's 682 2/3 pi. So I can add that to 640. That's 1,322 2/3 pi exactly, which times 3.14 comes out to be about 4,153.17, and that's in cubic inches. Okay, it's a pretty big pill right there. You wouldn't want to swallow that. Okay, what about this one? Okay, so we've got a ice cream cone type shape. We want to know the volume of that ice cream cone. Okay, so we've got the volume of a cone, which is 1/3 pi r squared times the height, plus a hemisphere, so that's half of the volume of a sphere, which is 4 pi r cubed. Okay, so 1/3 pi, the radius is 1.75 squared, the height is 6, plus half of 4/3 is 2/3 pi times the radius, 1.75 to the third power. Okay, so here we go. Let's see. 1 divided by 3 times 1.75 squared times 6. Okay, this is going to be 6.125 pi plus, let's see, 1.75 cubed times 2 divided by 3. This is going to be 3.5729 pi. Okay, this is going to end up being approximate. Okay, so I can add that to 6.125. Volume's approximately 9.6979 pi times 3.14. Volume is approximately 30.45 cubic inches. Okay. So I got a nice little worksheet here for you. It's got a few shapes on it for you to find. And there's 2 pages. Have fun with that. I look forward to seeing you guys in class. Have a great day.